Hi, this is Clark on Temptress. Today we're going to talk about what happens if the BMS in your lithium iron phosphate either fails or you just don't like it anymore. These are sensitive electronics, they can fail. They're probably the most likely case of a battery not being functional anymore. And I'm going to tell you today what you can do about it. Lithium iron phosphate batteries are pretty simply a group of cells that actually hold the power and make it available to you, and a BMS, an electronic device that keeps those cells from instantly destroying themselves. BMSs are there so that if you charge them way outside the envelope to the point where the cells would actually blow their valves, pop, lose their electrolyte, and be dead in a week, that it'll shut the battery down. They're a very important device. Be it said that don't count on them to properly charge the batteries for long life. That's a completely different thing. For that, you want a bank manager. I've got other videos on that. That's that device I do. I just always have to say that because people think a BMS is going to protect their batteries in all way, and they are not magic. They're also not magic because they're electronic. They are devices that, well, as we joke in the business, they're full of magic smoke, and you can tell because if something goes wrong and the magic smoke leaks out, well, they stop working. Electronics are pretty reliable until they aren't, and then usually you can't fix them, you can't do a thing about them. So, today we're going to talk about how to take this brain and put it into a battery and do a brain transplant. And why you might want to do that, well, number one, if you're out cruising or you're out and about and something happens very bad to your electrical system. I mean, the poster child of that is you just got hit by lightning, of course. You get hit by lightning, don't expect the BMS to work anymore. Don't expect a lot of your boat to work anymore. But I think the chances that your cells will actually work are pretty darn high. Also, they could just fail, just electronics fail, especially if you push them hard and they get hot repeatedly. A transistor can pop, it can lock in the on position. There's lots of things that can happen. But finally, and probably most common, is you bought some really cheap Chinese cells. You didn't even know if you're going to really like that whole lithium idea, so you bought what you bought. Maybe you bought like 3 100 amp batteries, and you just decided there's a feature that you find really important. Now the cells are working, you've tested them, they've been running, but maybe you need cold weather shut off and it's really important to you. Or maybe you just don't like having a BMS without Bluetooth and you really want that. For whatever reason, you've decided you want more out of those batteries. And of course the final way could be what I did. In taking this battery apart, actually in putting this battery back together, I screwed up. I shorted something that I shouldn't have shorted. Honestly, I thought it was going to be okay, but it turns out it wasn't. And I destroyed the BMS. I let the magic smoke out. So I found myself the proud owner of some really good cells. And actually, the cells in this particular battery are the best I've seen. They're matched, balanced. I'm sure it's just luck of the draw. And I needed to replace the BMS, so I did some research. Let's just say up front that do not judge this battery on the fact that I'm replacing the BMS. I think this was a fine battery. I think it was a perfectly reasonable BMS, but Clark screwed up. So I had to get a new BMS. Did some research. I had bought another BMS for another project I did a bit ago where I did the waterproof Pelican box. And I like that BMS. I like it better than a lot of them out there. But in doing the research, I also found this one. And I bought this one basically the same time. It just took forever to arrive. I now found it on Amazon. I'll put a link below and we'll put it in our Amazon store if you think you might want this one, so it's easier to find. The ads for these are not very good. You can't really tell if you're getting the right one or not based on the ads, so I'll send you the ad for the one I have for sure. This is called a JK BMS. I got this for 80 bucks. It really seems head and shoulders better than all the other ones that I've looked at. Definitely better than well, I don't want to name names. This is the one I'm recommending right now, and if at the end of the video I still like it, this is the one I would get. At 80 bucks, if you're going out cruising, you may want to just buy one and put it in a cupboard. It's not that big. I bought this because of all of its features. It's a Bluetooth BMS, as many of the good ones are now, so you can adjust parameters and see what's going on in the battery without opening the case. I was against that at first. I thought it was just silly. My joke was the electrons don't care. You really have to know about the balance of the battery, and the BMS is just the way to do it if it broadcasts Bluetooth. So it has that. It has cold temperature protection, which is really important. Obviously, it has high temperature protection, which is vital. You don't want the thing bursting into flames. It has the ability to put a cell pack heater in. I won't be doing that to this battery because this battery's life is going to be in the tropics, so just no sense. But if you wanted to, those heating blankets are not very expensive. You could retrofit one. I think the main thing I like about this one is it has what looks like the best active balancer I've seen. A lot of BMS have these passive balancers, and a passive balancer, I've got deep videos on this, but in short, they just put a resistance across one of the cell groups that just says, let's burn some power out of you. And they're very limited because when you burn power, you make heat, and then the only place it can put the heat is inside this device, and already it's kind of like, prone to overheating, has to rely on heat sinks and such. This has an active balancer, and it has a 2 amp supposedly active balancer. So if this sees one set of cells is higher in voltage when you're charging than another set of cells, it can actively take the power out of one and put that energy back into the ones that are low. And of course, that's an efficiency savings, but we really don't care about that. It's about thermals and speed. So this guy can move a lot of power. So I think this might be really important, especially if you find that the reason you want to change BMSs is your current BMS either can't keep up with balance on the cell pack, your cells might not be perfectly matched, or more likely, a lot of these just didn't seem to balance at all, or balance so incredibly slowly, I couldn't even tell they were balancing. This was a lot of these Chinese packs. Stepping up in BMS could fix everything, and 80 bucks for what could end up being like a 300 amp hour pack is a big savings. So enough of that. Let's talk about putting one in. I guess I'm showing you the back of it. It doesn't come with these tails. I put these on, and I'm not going to take them off because I put them on real tight, like they should be, and got all the lengths right. So I just don't want to take them off again. Anyway, the B minus goes to the actual pole on the battery, the minus pole on the battery, and the P minus goes to the pole on the top of the case. This is what goes to your boat in a negative way. The positive of all the cells goes right to the pole of the battery itself, outward. So this thing only controls things by the negative. And it has kind of 2 switches inside. It can let power go through into the battery or let power go out of the battery. And of course, it can turn on both switches, which is the normal situation. So this can just open up the cells to the outside world with whatever resistance the MOSFETs have, but that's what you have to do. Let the power go back and forth. It's a normal battery. If it ever feels it needs to shut down and stop taking a charge, it can shut down the ability to accept a charge, but still let you take power from the battery. And vice versa, if you ever really discharge the battery, it can shut down your ability to take any more power from the battery, because that will hurt them very fast too, but still allow the battery to be charged. It comes with some wires, and we have this set, and we have these. These are thermal pickups, and this will let it know if things are getting too hot or too cold. And this is the inter-cell connections. This is what hooks to every individual cell, so I can see what's going on in there. This will be the bulk of what we do to install this. You might notice there's a lot of wires here. This particular BMS can do a 4S, which is a 12 volt, or it can do an 8S battery, which is a 24 volt. So if you have a 12 or a 24 and you can get away with 200 amps of flow, this might just be the BMS for you. That's probably enough chatting about theory. Let's just get at it. I'm going to install this, and my method is going to be, first I'm going to use the existing wires that are coming up, and I'm going to solder them on to these wires so that I don't have to go right down to the cells and take everything apart quite so much. I'll hook them up, and then I will put the BMS in, hook up the big wires. I've got to figure out how to activate it. It's not obvious, it doesn't turn itself on, but there's things I found online and in the manual for different options for activating it. So we'll get it activated, and then we'll go through all the menu items and set things up. Though if it becomes a long video, I'm going to do that in a separate video. So if you see this video and like it, and you see a similar thumbnail, that will be how to finish setting it up. Also, the video on how to set up the BMS, all the parameters and what to set. There's a lot of wisdom in there. So if you have any BMS, I think that'll give you insight about how to set it for your application. Well, let's get at it. All right, diving in. Start here. Got to be a little careful because these are hot wires. And these scissors are not cutting this tape. All right, it's going to go like this, live about here. So I've got to have this be long enough to reach this point. And we'll start with the most negative. They've marked that in black. And connect it to the most negative. So cutting is always worrisome, but let's just do it. So I'll make it. You want them not too long because that's resistance, but you don't want them too short because, you know, that's a real problem. Now, let me see if I can put these. Okay, there's one. Number two. So go to this. Number two is this white one. And of course, number two on this side will be this one. If you solder something like this, you got to heat the wires and bring the solder to the wire, but a little bit of solder early makes a good thermal connection to the wire. So you kind of do it backwards to do it forward. Once that's cool, I'm going to try this. This is a smaller heat shrink. I was worried I would be able to pull it over the joint. Oh, that works perfectly. Okay, that's how we're going to do it. Yeah, it's going nowhere. Yeah, look at that. That looks nice. Okay, number three. Now, this final one is odd. It's got two jobs. This goes to the most positive terminal. This is the one that is the same as what goes out of the device. And for this particular BMS, you go to the next one as normal, and you go to the last one. And the last one is there, I guess, maybe to power the device, but it's definitely there to be like, this is the highest of the high. And the next one's there for balancing and all those other things, I suspect. There we go. Okay, that should be the hard part done. Since this tape is out, I'm just going to wrap it around here. But that shrink wrap worked pretty well. Okay, now we've got lines going to all of the batteries, cells. So just to refresh it for me, because I want to make sure I do this right. So the first one goes to the most ground, that's the black one. Then number 2, yep, that's number 2. Then number 3, right to the middle. Number 4 and number 5, 6, 7, 8, 9, last, whatever that is, goes to the hottest. So we've got that. Now, all I gotta do is hook up, well, let's do the thermal, that's important. The thermals go into this plug. Found manuals online and, you know, other people's tutorials and stuff. They're all quite readable. That's going to live there. I'll tuck these away a little later. All right, so next step here is to hook up the battery itself. I've already made up these jumpers. I did them from other wires I have around, so they're not the prettiest things in the world, but it's roughly twice what was in this battery before. And why I'm doing that is this battery only had a 100 amp BMS, so it could only pass a maximum of 100 amps, even though this is a 200 amp hour battery. Never confuse those two. Amps are the flow of power. Amp hour is the amount of energy available. It's kind of like amp hours are how big is your gas tank, and amps are how big is the carburetor, how fast can the engine go, how fast can the engine consume fuel. So let's get this hooked up. I think I'm gonna go get a wire tie to lock this thing down with. Seems like a good idea. Okay, nothing's where you want it, but found it. That ought to do. Okay, and I think it's now safe to hook up this set of wires. Everything else is hooked up. All right, that'll lock it down good. Don't need these, and I doubt they're ever going to get used for anything, but there's plenty of room in the case. They shouldn't get up to any mischief. I'm going to cut their ends right off though so that they don't have any exposed copper. And we'll run them off to this safe side. There we go. Thermals. Put one right down there. And I'll put one over here, right up close to the batteries, cells. And of course there's one in the electronics package. Now, for the part that's been making me the most nervous, this is dead. This is non-functional right now. It has to be turned on. And they say to turn it on, take my multimeter. I set it for continuity. And I place the probe here and here. And it's supposed to come on. And there's a light somewhere, and it didn't come on. That was the first way to do it. Darn. There's 3 ways to turn this on. That was one of them. Oh, they said if it didn't work, flip it around. Maybe I got it backwards. The idea being that there's a small voltage coming out of the meter. But I guess the fluke puts out too little. Second way to do it is there's a couple pins here that are actually the switch to turn it on, but I don't have the plug. And I could try to touch those poles. I'll do that if I have to. Kind of wish I hadn't tied it down now. And the final way was with a 9-volt battery, kind of the same thing as this meter. And I think I'm going to shut down filming now, get online, read the manual. And I've got my bench power supply, so I'll use that as my 9-volt battery. Be back in a bit. All right, little bit looking up the manual, and there are other options. So if this doesn't work, what they recommend is charging it at 5 volts higher than the batteries currently are at, which is pretty high, but you know, I'm sure it's up to it. Besides, it's a 24-volt device, so I'm absolutely sure it's up to it. So we're going to give that a go using the bench power supply. So I'll turn this on. I'll set its voltage right down where the batteries are now, so we can bring it up bit by bit. I found out that the little light is over here, and it has a little noise maker of some kind, so we should hear it come on. So I'll hook the ground wire to what will be the battery terminals. And I'll hook the hot wire to, again, what will be the battery terminals. I'll do it right in here. Here we go. It's down. Turn on the power supply and bring the voltage up. So I'm at 12.7, you know, well below. This is like 13.2, right? Coming up. There's 13.2. It's not taking any current. Coming up. 14 volts. 15 volts, and it goes beep. Okay, I'm going to assume it's on. I'll bring this back down a little bit. Light's blinking. It came to life. Well, that's cool. Okay, this battery is basically ready to go now, physically, except for the setup. I think I will just tuck it together, finish it up now. I'm going to hook up the leads to the batteries themselves. This guy goes to the main positive. I'm going to back them up with another wire. As I said before, because this is a 200 amp BMS, and really these were perfectly adequate wires for a 100 amp. So we might as well add a little more copper. More copper, more better. All right, still good. Man, I'm gonna need a wrench. Okay, and then the grounds, they come from the P minus. All right, they're on there pretty good. I'll silicon this down later, but all to do now is line it up and tap it back together. Now, let's take a look at the app. I've loaded the app on this tablet. Okay, so the first thing we're gonna do is start the app that came with this. There's a one of those codes right here on the front of it you could take a picture of. I just went to the Play Store and I typed in JK BMS. It came right up. The icon is this little cloud that they use. And I hit scan. There's a new one. It's interesting here. I've got Bank Manager 0, Bank Manager 1, Bank Manager 2. Those are the 3 bank managers that I've developed running on Temptress right now. And then this JK just popped up, which is the same serial number. So we know that it likely uses the same protocol, which is BLE, Bluetooth Low Energy, the more modern one. So I will click that. Here's the main screen. It's telling us that we're 13.29 volts. You know, I'm gonna spend some time in this. I'm gonna just stop the video now because this is a success. We have it physically installed and physically working. I'm gonna close this video down and say bye and see you next time. But next time I'm gonna activate the BMS with the app and get it all set up. I know this one has a slew of parameters that you can adjust because this works for both lithium ion batteries and lithium iron phosphates and all different cell counts and all kinds of things. So come back next time and we'll go into how to finish this up. Even if you're not setting one of these up, you may be interested in the next part because a lot of the parameters are going to be the same for any BMS you have. So anyway, thanks for joining me. This is Clark on Temptress. Hope you have a nice day.